This Zoom session is being brought to you by the fractal Heart of Gold forming. These are earlier versions. This is one stage later, one later, one later, one later, whatever. Okay, for today, we're going to do double angle and half angle formulas, section 3.6. We start with the angle addition laws as follows. Cosine of alpha plus beta is cosine, cosine minus sine, sine. Sine of the sum is sine, cosine plus cosine, sine. Tangent of a sum is tangent plus tangent, all the divided by 1 minus tangent times tangent. So for a double angle formula, we'll just let beta equal alpha. Then alpha plus beta is 2 alpha. So you have cosine of 2 alpha is cosine alpha cos alpha, that's cos squared alpha, minus sine sine, that's minus sine squared alpha. Letting beta equal to alpha here, this simplifies to sine of 2 alpha equals 2 sine alpha times cosine alpha. Letting beta equal to alpha here and here, you get tangent of 2 alpha equals 2 tan alpha over 1 minus tan squared alpha. Now, we usually don't use this version of the double angle formula for cosine. Since cosine squared is 1 minus sine squared, we can rewrite this as 1 minus twice sine squared alpha. And since minus sine squared equals cos squared minus 1, we can also rewrite this as 2 cos squared alpha minus 1. These are the double angle formulas that we usually use, simply because it uses only one of cosine and sine. So, okay, these are the double angle formulas. So, for example, now we can run them backwards to try and get a half angle formula. Here's cosine of 2 alpha. Here's cos squared of alpha. So let's find cosine squared of alpha in terms of cosine 2 alpha, or ultimately, yes. So first, we add 1 to both sides and divide by 2 and get cos squared alpha equals cosine 2 alpha plus 1 all over 2. Here, solving for sine squared alpha, we do some transposing, and we get that sine squared alpha equals minus cosine 2 alpha plus 1 all over 2. Now, if we let this 2 alpha, call that theta, so alpha is theta over 2, then this becomes cos squared theta over 2 equals cos theta plus 1, that divided by 2. And sine squared theta over 2 is minus of cos theta plus 1 all over 2. All right, and okay, for the next step, we take square roots. We get a plus or minus depending on which quadrant theta over 2 is in. And reverse the order because it's easier to write 1 minus cosine rather than negative cos plus 1. So cosine of theta over 2 is plus or minus, depending on quadrant, the square root of 1 plus cos theta, that over 2. Sine of theta over 2 is plus or minus square root of 1 minus cos theta, that over 2. These are half angle formulas. And if you take the ratio sine over cosine, you get a ratio of these square roots, and the over 2's cancel. We're left with square root of 1 minus cos theta divided by square root of 1 plus cos theta, like this. Now that's actually, and we still have this plus or minus depending upon the quadrant. Now it turns out that if you look on page 244, we can do a somewhat, I think, similar version that cosine of theta over 2 is 1 minus cosine theta over sine theta. It also equals sine theta over 1 plus cos theta. From this, you can derive these, but there's that plus and minus still hanging around. And this is more specific. So in that sense, probably a slightly better formula. All right, so examples. We're given that sine theta is 3/5 and it's in quadrant 1, an acute angle. Find sine of 2 theta, cosine 2 theta, sine of theta halves, and cosine theta halves. All right, so first quadrant, sine is 3 over 5, opposite is 3, hypotenuse is 5. Then by Pythagoras, we derive that the adjacent side is 4. All these are positive numbers because this is the first quadrant. So sine is 3 over 5, again, and cosine is adjacent over hypotenuse, 4/5. Now we have all we need. Sine of 2 theta is 2 sine theta cos theta. That's over here. So we just plug it in. 2 times 3/5 times 4/5. That's 24 over 25. Cosine 2 theta. Well, there's a cos squared minus sine squared formula. There's 1 minus 2 sine squared, and there's 2 cos squared minus 1. I recommend using the, so to speak, freshest ingredients. We were originally given sine, and cosine is derived, so there's a potential for error. So we start from the, like I say, freshest ingredients and say that cosine of 2 theta is 1 minus twice the square of the sine. That's 1 minus twice the square of 3/5, which after a bit of algebra is 7/25. And therefore, there's a 7, 24, 25 triangle, right triangle. Now this is in quadrant 1, theta is. So theta 2 is also in quadrant 1. So all the half angle formulas have a plus. So sine of theta halves is plus root of 1 minus cos theta over 2. Cos theta over halves is plus root of 1 plus cos theta over 2. This is root of 1 minus 4/5, that over 2. This is root of 1 plus 4/5 over 2. After a bit of arithmetic, this first one is root 10 divided by 10. And the other one is 3 root 10 divided by 10. All right. Cosine of 165 degrees is what? All right. Now this is in the second quadrant, therefore the cosine is negative. And what's more, 165 degrees is half of 330 degrees. So this quantity is cosine of half of 330 degrees minus, because it's in quadrant 2, minus of root of 1 plus cos 330 over 2. Cosine 330, that's 30 degrees short of a cycle, and so therefore it is a positive cosine and a negative sine. We have sides 1, root 3, and 2. Cosine is root 3 over 2. So this would be 1 plus root 3 over 2, all over 2, which after a bit of algebra is minus root of 2 plus root 3, all that divided by 2. Here they asked to prove an identity. The sine of 3 theta divided by sine theta minus cosine 3 theta over cosine theta equals 2. Okay, we start with the left side, the sine 3 theta over sine theta minus cosine 3 theta over cos theta. We'll combine the fractions. A over b minus c over d is AD minus BC over BD. So sine 3 theta cos theta here minus sine theta cos 3 theta here over sine times cosine. All right, now this sine cosine minus sine 3 cos theta minus cos 3 sine theta, that is a sine of a difference, sine of 3 theta minus theta. We'll multiply numerator and denominator by 2 to get 2 sine 3 theta minus theta over 2 sine theta cos theta. The denominator, 2 sine theta cos theta, is sine of 2 theta. And lo and behold, 3 theta minus theta is a 2 theta, so we're getting 2 sine 2 theta over sine of 2 theta. The sine 2 thetas cancel and left with 2, which equals the right-hand side. And it is proven. Okay, I think we're done with this then. Okay, good. So these are the examples we needed. These are, when they ask for proven identity, I will ask for a complete proof, starting from left to right, for example, or from both to a common expression or some such. All right.